So here's another proof example. Once again, we're going to start out our problem by looking at the given information. That given information is in line 1. So we start out with our given. Also notice that what we are trying to prove is our last statement, and we never know that that is proven. We have to have some sort of definition, postulate, property, or theorem. So if we look at our information, we were given that T is the midpoint of AM in the diagram. I'm going to put T in the middle. We're then told to apply the definition of midpoint. Remember back to chapter 1, our definition of midpoint down close to the bottom of the page. It bisects or divides our segment into two congruent segments. So we have a midpoint. We are going to get two congruent segments. So the two segments we're going to get are on each side of T. So we're going to get segment AT is congruent to segment TM. From line 2 to 3, so they've given us the statement, we have to provide the reason. The difference between 2 and 3 is our congruence, changes to equal. Once again, back in chapter 1, our congruent in the middle of the page there, highlighted in dark red. If we have congruent segments, they have the same length. So that is our definition of congruent. Make that look a little better. The next one is probably the hardest one that you're going to have to do. So be careful with this one. We have addition, but this is not the addition property. The addition property has an addition added to both sides of an existing equal statement. This is only one addition problem, not on both sides. This one, we're going to have to look at the picture. We see that these AT and TM are the parts, and AM is the whole thing. And back in chapter 1, we had a postulate about those that said that we can add the parts and set it equal to the whole thing. So we're going to apply our segment addition postulate. We have added the two parts and set it equal to the whole thing. For the next step, we are going to do substitution. This is where we get to replace something. So remember in chapter 2, substitution is where we can replace an item. So from my addition problem, if I look at these lines, I can replace, since what I'm trying to prove wants to keep the AT, I want to replace the TM. So keep the AT, replace TM with what it's equal to, AT, and we keep the AM. The next one is something that we haven't really talked about. This one is where we have taken an addition problem and simply simplified our addition. We have AT plus AT, so there are two ATs. So this is simplify. I will also count this if you call it substitution, because we've replaced the addition problem with what it's equal to. And then last, we are able to get, if we use our calculation process, this 2 needs to be removed. It is multiplication. And remember that we can use the division property to remove multiplication. So we can do the division property, or we can do the multiplication property. We can do the division to get rid of the multiplication, or we can multiply both sides by 1/2 to get rid of that multiplication.